Okay, so good afternoon or good morning. I'm deciding to shoot this video for the Chapter 5 test, both to post to the internet and because this way y'all can correct these in class with the supervision of the substitute, since I will not be here on Wednesday due to my certification test that I'm taking for speech. So, let's take a look at the questions. Of course, you will need a calculator for the calculator permitted section, but for the calculator prohibited section, we don't need no stinking calculators. Okay, so the first question is this function 1-to-1? Well, you know that it's a quadratic, and you know that fundamentally the quadratic, this is a quadratic with a positive upswing, and so we know it looks like this. It has a positive leading coefficient. Where it is on the axis is not that interesting. For a function to be 1-to-1, it needs to pass the vertical line test to prove that it's a function, and you have to pass the horizontal line test to prove that it is a 1-to-1 function. So, does this pass the horizontal line test? Very obviously not. You have 2 points of intersection, and there it is. So, it does not pass the horizontal line test. Number 2, evaluate the log 3 of 9. This was high. Do you recognize that you are being asked to find the log 3 of 3 squared? Simple arithmetic tells you that 9 is 3 squared. Log cancels base, and base cancels log. Thus, the only thing that remains is 2. Okay, the next one, you have been given a function and you are expected to find its inverse. To find the inverse of a function, you switch x and y. And so you say now that x is equal to 3y minus 5, and then you solve for y. You add 5 to both sides, and then you have x plus 5 is equal to 3y. To get y by itself, you divide the whole thing by 3. And so you have y is equal to x plus 5 divided by 3, which is b. Okay, for the next set of questions, you are expected to use the table to evaluate the answers for questions 4 through 8. Now, first thing you had to recognize is that the function of a sum is the sum of its functions, and so you were going to find the f of 2 plus the g of 2. Well, I look at my f function, and where x is equal to 2, the f of 2 is 3. And where I look at my g function, and where x is 2, g is 4. And if you can't do 3 plus 4, you need to not be in high school. Correct response was 7. The next one was very similar. You had to recognize that the function of a product was the product of its functions, and so you would take the f of 4 and multiply it by the g of 4. Well, the f of 4 is 2, and the g of 4 is 0. And of course, 2 times 0 is 0. Now, number 6 and number 8 were compositions. The g of f of negative 2 is literally the g function evaluated at the f function of negative 2. And so the first thing you would have to do is you would have to find the f of negative 2. The f of negative 2, of course, is 1. And then you would have to evaluate the g of 1. Well, the g of 1 is 2. And so your final solution was D. Number 7 was the g over f of 4. So you had to find the g of 4 and divide it by the f of 4 and assume and verify that you're not dividing by 0. So the g of 4 was 0, the f of 4 was 2, and of course 0 over 2 is 0. Inverse, and now for the next one, f of g of 4? Well, works the same way. F of g of 4, you had to evaluate the g of 4. So you go to where x is 4, g is 0. And now you need to evaluate the f of 0. Well, the f of 0 is 4. And so that was D. And that's how you do the first 8. Now let's take a look at the back. So you were given an exponential form. And you were told that the f of 0 was 3 and the f of 3 was 24, and you were being asked to find c. Well, you already know that the f of 0 is 3, which is the leading coefficient times the base where x is 0. Well, a to the 0, assuming a is not 0 itself, any term to the 0 power, is 1. So basically, this just told us that c is equal to 3. And so this was a high, do you know what you're looking at? Now, to go from 3 to 24 is to multiply by 8, and that was after 3 iteration. The base was actually 2. The function is actually f of x was 3 times 2 to the x. But in this case, they were only asking for the leading coefficient. Now, for number 10, they asked you, what is the natural log of 1? Now, I had told y'all in class, I had y'all strike it in your notes, and I had said it several times, and I had even told you it was going to be on the test, that any term, whenever you take the log of 1, whether it's a natural log, a common log, or a log of an actual base, is going to be common log of a natural base. The log of 1 is always 0. Because if I think about it, 1 is actually the Euler constant to the 0. So I have the natural log of e to the 0, natural log cancels e, and so all I'm left with is 0. Okay. The next one, which of the following is not a valid expansion of the natural log of y over x squared? Now, in this case, I'm taking a quotient of logarithms. Whenever I'm taking a quotient, that means I am subtracting the log of x, the natural log of x squared from the natural log of y. Now, this is actually our first answer choice. Now, the key thing is it asks us which is not a valid expression. So, that one's out. Now, the other thing is whenever I have an exponent here, that exponent can become a coefficient. So, that's actually B. Now, C and B are actually the same thing, just using the commutative property of addition. I just moved some stuff around. Whereas here, the coefficient 2 is being applied to the natural log of y, which does not belong. And so that is the correct response. Number 12, a lot of people had made some interesting mistakes on this. So you knew that you had the Euler constant set to the 1/10 of x is equal to 5.2. So the first thing you're going to do is you are going to cancel your Euler constant by using the natural log of both sides. And so you have the natural log cancels e, which is 0.1x is equal to the natural log of 5.2. Now, what is the opposite? 0.1, another way of saying that is 1/10. And so to cancel 1/10, 1 simply multiplies by 10. So x actually winds up being 10 times the natural log of 5.2. Now, C and D are not the same because this 10 is not being distributed. It is actually an exponential. It's actually the exponent of 5.2. So, the correct response was C. Now, number 13 was high. Do you know how to transition something from logarithmic form to exponential form? Your base is 3, your exponent is 4, and your term is x. After that, it's just a matter of evaluating 3 to the 4th. The most common incorrect response was 12 because people multiplied when they should have exponentiated. 3 to the 4th is actually 9 times 9. 3 squared times 3 squared, which is 81. Final solution. Number 14 was a little bit more fun. You have the log of x is 1.5. Now, you have a log of x is equal to 1.5. Your base of a log, when you don't see it, of course, is 10. So I'm asking you to say that x is equal to 10 to the 1.5. At this point, I asked you to do some elementary arithmetic and to recognize that 10 to the 1.5 is actually 10 to the 3 halves. 3 halves, well, that's merely 10 to the 3rd, and I'm taking the square root of that, which is the square root of 1,000. That one was high. Do you remember your exponent rules? And high, do you remember simple arithmetic? For the last one, I asked you to evaluate the natural log of e. Natural log cancels the Euler constant. The Euler constant was set to the first power, so your final solution was 1. That's it for the multiple choice. Next track will be the open response with calculators. Okay.